Okay, Algebra 2 Longhorns. Here's our review for Test 2.2, and we're going to start with graphing systems of inequalities. All right, for this first problem, we have two inequalities in standard form and a graph. And what I need to do is I need to rewrite these inequalities in y equals mx plus b form or slope-intercept form so that they're a little easier to graph. So I'm going to go ahead and do that, and then we can graph these lines and shade. All right, so I have converted both of these standard inequalities to slope-intercept form, and now I'm going to graph these two lines. I'm going to do the first one, which is a greater than inequality. I'm going to do that in blue. And the greater than or equal to inequality, I'm going to do that one in green. Okay, so you should notice that when I graphed this line, I used a dashed line instead of a solid line because our inequality is a greater than symbol, not a greater than or equal to. So it's not going to be equal to, so I'm going to use a dashed line. And then I'm going to shade above the line. So above this line would be up here. So I'm going to go ahead and just kind of shade that above the line. Now I'm going to graph the other line and shade it. All right, so this line is a solid line, so you can see right here where I've graphed this line. Y-intercept was -1 and the slope was 1/6, so rise over run gets me right here. And if you'll notice that on here, on this graph we shaded above the line and we had the blue all in here, and then when I shaded above this line I shaded this in green. So our solution area is this area right here where the blue lines and the green lines both cross at the same time. This is where all of our solution points are going to be, right here in this area. Not including this blue dashed line though. Just remember that. Any points that are along this blue dashed line are not going to be in the solution set. But everything above that line and everything above this solid line here are all part of the solution set. Okay, I'm going to do the same thing with number 2. I'm going to go ahead and work this out, and then I'll explain. Alright, so you'll notice that when I solved for y in this first equation, this one right here, I have to end up dividing by a -2. And as soon as that happens, this makes my inequality flip. So my inequality flips over to a greater than or equal to. So don't forget about that. If you have to divide by a negative, that's going to make your inequality flip. Okay, so I'm going to graph this first inequality in blue and the second inequality in green. Alright, so I've graphed the line y is greater than or equal to 3/2 x minus 8, which is going to be a solid line, and I shaded above the line. Alright, so the green line, the y is greater than less -1/4 x minus 1, is a dashed line, and I'm shading above that as well. So just remember the area that contains the solutions is going to be the area where the blue and the green cross each other. So that's going to be this area right in here. Above the blue, above the green dashed line, and anything in here will be a solution to this inequality set. Okay, so the next question asks, determine which ordered pairs are solutions for either graph. Okay, so I'm going to call this one graph 1. And I'm going to call this one graph 2. And I'm just going to put underneath these points which graph they would be in if they were in one of these graphs solution sets. So for -2, so I'm looking at this first point for -2, and if I'm looking at my first graph, if I go over 1, 2, 3, 4, and down -2, it's definitely not in graph 1. And if I look at graph 2, 1, 2, 3, 4, and I go down 2. I do have a point on graph 2, but remember that line is a dashed line. So the points that are on that dashed line are not going to be part of the solution set. So we'll have to cross off 4-2 as one of our possibility, or 4-2 as one of our possibilities. That's not in either set. So I'm going to go through each one of these points to see whether they fall in a solution set or not. Another way that you can check to see if the point you have is in the solution set is to plug those points into your original inequalities, and if it makes the statement true, then that point is in the solution set. But remember, this is a system, so it has to be true for both inequalities. If it's not true for both inequalities, then it's not part of the solution set. Alright, so this is what I found. There's only 2 points that are in the solution sets for these graphs. 8, 4 was in both graphs as a solution, and 0, 6 was a solution in graph 2. Let me know if you found something different than what I have, and we can discuss it in class. Okay, questions 4 and 5 are very similar. Really all you need to do for these graphs is look at either the vertical line or the horizontal line. For this graph number 4, the vertical line is where x equals -9. So it really doesn't matter where those two lines intersect. The x value is going to be -9. Well, we only have one of our answer choices where x is -9, and that's our answer choice D. And this other one, the y value is 2. So no matter what happens with the second line, the first line, the y value is 2. So we know that our solution is going to have a y value of 2. So the only answer choice of the y value of 2 is answer choice B. Alright, on the next page we have some problems where we have to solve by hand. And what we're doing is we're solving for x, y, and z, and we're solving by hand. You still have to show your work. Yes, you can do this in the calculator, and yes, you can get the values for x, y, and z, but we also want to make sure that you know how to do it by hand. So the first thing I'm going to do is I'm going to solve for this x right here. I'm going to solve for this x, I'm going to get that value, and then I'm going to plug that up here into this x, and I'm going to solve for z. Okay, so here I solved for x and I got -5. And then I took this -5 and I plugged it in here into this top equation. I plugged the -5 in for x. So -3 times -5, I plugged it in, plus y minus 18. And I simplified this. And when I simplified it, I got z equals y minus 3. Now I can take this y minus 3 and I can plug it into this equation. I can also plug in my -5 for x. And when I do that, I can eliminate 2 of my variables and then just be left with the y variable, and then I'm going to solve for that. Okay, so I've taken my y minus 3 and I substituted it right here in for z in this equation. So I replaced this z with y minus 3. And I also replaced the x with -5, since we know that x is -5. Then I solved for y. So I simplified this down. I got -4y plus 2y minus 6 plus 7. And then I combined like terms. And then I subtracted the 1, so now I have -6 equals -2y, y equals 3. So now I know that x is -5 and I know that y is 3. So I can take these two values and I can plug them back in to the top equation and solve for z. Okay, so when I substituted in my -5 and my 3 into my first equation, I get that z equals 15 plus 3 minus 18, which just means that z equals 0. So my solutions are x is -5, y is 3, and z is 0. And here you see I wrote them out separately in a box. My x is -5, my y is 3, and my z is 0. Okay, on number 7, I'm going to solve for y first, and then I'm going to plug that in to the next equation and solve for z. And then I'm going to take that and I'm going to plug it into the last equation to solve for x. All right, so far I've solved for y and x, and now the last thing I need to do is solve for z. So I'm going to take the y that I found, the -2, and the x that I found, 0, and I'm going to plug that into the middle equation, z equals 3x plus y minus 3, and I'm going to solve for z. All right, so when I plug in my -2 and my 0, and for z equals, I get z equals a -5. So my solution set is 0, -2, -5. All right, in problem number 8, we are determining which graph will have the narrowest and which will be the widest graph. So we really only need to look at this value right here of our a. It doesn't matter if it's negative or not. This doesn't have anything to do with how wide or narrow the graph is. This negative sign here only has to do with the reflection of the graph. If there's a negative sign here, it just means that the graph is reflected vertically. So because there's a negative sign doesn't have anything to do with how wide or narrow the graph is. So really all we need to look at is this value here, this one, the number 3, this one, and the 2. Okay, so what I'm going to do to make things a little bit easier for myself is I'm going to go ahead and convert these numbers all into decimal form. Decimal form is a little bit easier to read, so I'm going to do that. 5 halves is converted to 2.5. Then I have 1 half, or 0.5. Then I have the 3. Then I have 2/8, which is just 1/4, which is 0.25. And then the 2. All right. So the greater the number is greater than 1, the narrower my graph is going to stretch. So just remember, think of it as a rubber band. The longer you stretch the rubber band vertically, the narrower it gets. So if I'm stretching a rubber band up and down, it's going to get smaller and smaller width-wise as it gets longer and longer vertically. So that means that as my a value gets larger than 1, the graph gets narrower and narrower. So for a narrowest graph, I'm going to pick the number 3 because that is the largest number that I have greater than 1. For the compression or the widest graph, if I'm flattening out my graph close to the x-axis, if I'm flattening it out like a pancake, I want that value for a to be in between 0 and 1. And the closer it is to 0, the flatter it gets. So of our decimal points, the one closest to 0 is this 0.25. So that one is going to create the wide graph. This 3 creates my narrow graph. All right, so question 9 is very similar to a question you got on the last test. And it asks about point M. It says point M is 4, -3, and it's on a graph of f of x. The graph has been transformed to create g of x as follows. G of x is -1/2 of f of x minus 3 plus 5. What is the y coordinate of m prime after this transformation? Okay, so what we really need to look at right here is just what happens to the y value. It's only asking about y. So it's not asking about the x. It's only asking about what happens to y. Well, if you remember from your transformations, anything that happens outside of these parentheses right here, these are all vertical changes. These changes affect the value for y. The value on the inside of the parentheses affects the horizontal changes. This is what's going to affect x. So if we're only concerned about what's going on with y, then we only need this y value here. This x value is not affected. So we're just going to look at this -3 and we're going to apply these transformations. The first thing I'm going to do to -3 is I'm going to multiply it by a -1/2. Then I'm going to add 5. So remember to use your PEMDAS rules. You're going to multiply first and then add. Okay, so I multiplied -3 by -1/2. That gives me 3/2 or 1.5. And when I add that to 5, that gives me 6.5 or 6.5. So either way you want to write this either way is fine. All right, so in the next two problems, we're just writing a system of inequalities to model each situation. Okay, so let's look and see what we have here in this problem. All right, so we have $4 per hour and $7 per hour. These are her two jobs, and we would call this one X, and we would call this one Y. And the most amount, or the amount of money she wants to make has to be at least $65. So what at least means is that she wants to make $65 or more than $65. So if we ever see the words at least, that means that's the minimum, and then we want to make more than that. So greater than or equal to. Greater than or equal to. So 4x plus 7y is greater than or equal to 65. The other equation we're going to have is the jobs that she's doing and the hours that she works. So she can only work so many hours at X, so many hours at Y. The most she can work is 13 hours. She can't work more than 13 hours. So this needs to be X plus Y is greater than or equal to, forgot the equal to here, greater than or less than or equal to 13. So X plus Y is less than or equal to 13. Okay, in this next problem, we're buying candles, and the small candles cost $3.50 and the large candles cost $5. And we only have $80 to spend. So 3.5x plus 5y has to be less than or equal to 80. We cannot spend more than 80. Also, the number of candles that we can purchase, small candles plus large candles, needs to be greater than or equal to 20. So we want at least 20 candles, which means that we want at least 20 candles, but more than 20 candles would be okay too. So we're going to write x plus y is greater than or equal to 20. All right, for these two graphs, we're going to write the system of inequalities from the graph. So the first thing you want to look at is where the intercepts are, and then you want to look at the slopes. You also want to look at whether the line is dashed or solid, and you want to look to see where it's shaded, above or below the line. That will determine which inequality we're going to use in our system. Okay, so the first line I wrote an equation for was this one right here. And so the intercept, the y-intercept for this line is -2. So here's my -2. And the slope of my line is -1, -1x. So y is greater than -x minus 2. It's shaded above the graph, that's why it's greater than. And it's not equal to because it's a dashed line. Okay, what about the other one? Well, this one has a y-intercept of -7, so there's my -7. This one has a slope of 1/2, so 1/2 x. It's also shaded above the line. So since it's shaded above the line, it's going to be a greater than symbol. So y is greater than 1/2. Y is greater than 1/2 x minus 7 is the other line for my graph. Okay, so for this graph, my first line, I went ahead and I wrote an equation for this solid line right here. Since this line is solid, I'm going to use a greater than or equal to or less than or equal to symbol. And I have to look to see where this is shaded. Since this is a positive slope and the shaded area is to the right of the positive slope, I'm going to have to use the less than symbol. If it was shaded on this side of this line, it would have been greater than. But since this part right here is on the right side of this positive sloped line, that means that this area is less than this line. So I'm going to use the less than or equal to symbol in this case. My y-intercept was -5 and my slope was 4. Rise over run. So my inequality here is y is less than or equal to 4x minus 5. For the other line, the dotted line, I started with my y-intercept of 8. And since for this dotted line, it's shaded above the graph, this is a negative slope. So negative slope lines, if they're shaded up here, this is considered to be above the line. Then this is greater than, but not equal to, because this is dashed. So here I use the greater than symbol, but not equal to. The slope for this one was -1/3. So down 1 over 3, -1/3, and the y-intercept was 8. So y is greater than -1/3 x plus 8. Okay, so here we have some word problems, and we have to write some systems to be able to solve these. So in each case, we're going to write this system of equations, and then you can either use your calculator or you can solve them by hand or use any other method that you know, elimination, substitution, any of those other methods are fine, even graphing if you wanted to try to graph. So I'm going to go ahead and set these up for you so you can see what they should look like, and then I'm going to let you solve them in your calculators. Okay, so this is how I set this up. All of my apples, apple X, apple Y, and apple Z, which represented their different kinds of apples, needs to equal 21. We have 21 pounds. So 21 pounds of each of these three kinds of apples together. These are the prices for each kind of apple. So money, money, money equals money. We had $25 to spend. So make sure you line these all up, money, 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 money. And then the last hint we had was that we needed to buy twice as many red delicious apples as the other two combined. Well, y represented my red delicious apples. So y equals 2 times x plus z. That would be these two combined. And that would be my 3 equations. And so I can set this up and plug it into my calculator and solve it, or I could try to solve it by substitution. Whichever method you want to use is fine. On the test though, I might recommend using the calculator on this. It'll save you some time. Okay, so our solutions end up being 5, 14, and 2. Okay, so for the Vaca Printing Press Company, we have 2 kinds of models, A and B, which I'm calling X and Y for the purposes of being able to put it in my calculator. Model A does 70, Model B does 55, for a total of 905. So Model A plus Model B equals 14 total models. So I put this in the calculator and I get 9 Model A's and 5 Model B's. Okay, this problem is really funny. Who ships bicycles with the wheels in a separate box? I don't know. But we're going to go ahead and put this system together and see how many tricycles were shipped. Alright, so for this problem I let X represent my bicycles and Y represent my tricycles. we had a total of 17 boxes, which means we had a total of 17 total bicycles and tricycles. So I added x plus y to get 17. The next thing is I used the numbers of wheels per each kind of cycle. So the bicycle has 2 wheels and the tricycle has 3 wheels. So 2x plus 3y equals a total of 45 wheels. I set that system into the calculator, and the result that I got was 6 bicycles and 11 tricycles. Okay, so the next problem is at the Apple Pan, 2 burgers and 3 orders of fries cost $19.75. 5 burgers and 2 orders of fries cost $37. If Coach Reeves bought lunch for Miss Vaca because she's so nice, and they each had a burger and an order of fries, how much would the cost be before tax? So basically what we're getting from this system is the price for each burger and the price for each fries. That way we know how much it's going to cost for these 2 lunches. Okay, so each burger cost $6.50 and each order of fries cost $2.25. So the question was, if Coach Reeves bought lunch for Miss Vaca because she's so nice, and she is, and they each had a burger and an order of fries, how much would the cost be before taxes? So if they each had a burger and fries, if I add this together, I get $8.75. And $8.75 times 2, because we had 2 of those, that's going to be $17.50 before taxes. And so that's how much it would cost. Okay, in problem 18, we have a system of equations. That's a 3 by 3. And it just says solve. It doesn't say how. So guess what I'm going to do? I'm going to use my calculator. Okay, so one of the things that you need to do when you're putting these equations into the calculator, make sure that you're using the negative button and not the minus button for numbers that are negative. For the operation minus, you're going to go ahead and use the minus button. So for these buttons, you would use the minus. But for this one in the front of the 3, for this coefficient, you would use the negative button, which is right under the number 3 on your calculator. Okay, you would also use that negative button right here for this negative sign in front of the 1. If you try to put minus signs where there should be a negative sign, the calculator isn't going to work for you. So just make sure that you're using the right button. The other thing you want to do is, if you've got variables like r, s, and t, you can use r, s, and t in the calculator, but that means that you would have to go in and you would have to change the settings on your calculator so that your calculator is reading r, s, and t instead of x, y, and z. I think it's easier just to change r, s, and t to x, y, and z to begin with, and then just use those variables, because it really doesn't matter what your variables are. And the calculator, it defaults to x, y, z, so just go ahead and change these to x, y, z. So I changed r to x, I changed s to y, and I changed t to z. And I solved it in the calculator, and I got some pretty interesting looking fractions here. I got negative 233 over 19. For my x, I got negative 189 over 19 for my y, and for my z, I got 274 over 19. Now there could be a couple of reasons why we get these odd looking fractions. Maybe when we typed this equation, perhaps we made a mistake and typed something that we weren't supposed to, or transposed a number. These kinds of things sometimes happen. So we do get solutions, even though they're fractions. It's okay, just write down whatever it is you got from your calculator. Okay, so when I do this system, I end up with 4, -3, and 1 for my x, y, and z, or for my a, b, c. Okay, so the next activity is a matching activity. We're matching the point that's given with the graph. And so we're going to start with point -2, 3. I'm going to check each graph to see if point -2, 3 is part of my solutions. -2, -3 is not a solution to graph A because that happens to be the intersection of those lines, and both of those lines are dashed lines, which means that any points on those lines are not going to be in the solution. So, not A. -2, -3, do we have that in B? Yes, we do. So we're going to say B. Is it in C? Nope. Is it in D? Let's see. -2, -3. Yes, it is. So B and D for this one. The next one, -2, or -1, -2. Yes, it is in A. -1, -2 is not in B. That's on the dashed line. -1, -2 is not in C, even though it falls on that solid line. That's not part of the solution set. Remember, the solution set is in the shaded region, and that's not in the shaded region. And then the next one, is it in D? -2, -1, -2. No, it is not, because this point here is not in the shaded region, and it is actually on the dotted line, so it is not part of the solution set. So for -1, -2, the only graph that fits is A. Right there's a point. Okay, 0.32. Over 3, up 2, definitely A. No about a doubt it. Okay, how about graph B? 3, over 3, up 2, nope. How about graph C? Over 3, up 2, nope, because this dashed line stops that from being a solution. So it cannot be on the dotted line. All right, let's try the next one. Over 3, up 2, no. So for 3, 2, the only graph that includes that point as part of its solution set is A. Okay, so for the last problem, number 21, there are so many ways we could solve this. One of the ways is to use the calculator and do a system of equations problem for each one of our answer choices. That's one of the things we can do. Another thing we can do is take the point they gave us, the -9, 14. We can plug that in, substitute it in to the equations, and see if it's a solution. And the other thing we could do is, we could use substitution, elimination, graphing. There's so many different ways that we could try to solve this. I think what I'm going to use is substitution. I'm going to go ahead and substitute the -9 and 14 into the equations to see which one would give me the solution. Alright, so after plugging these all in, I find out the only possible correct answer is A. I'll use a different color. I'm going to use the black one. A is the correct answer. I also could have used substitution, elimination. I could have used the calculator to graph a system of equations. Lots of things I could have done, but I think the easiest way for me was to just plug in the values for x and y into the equations to see which one was true. And that's the end of the review. Good luck on your test. I hope you all get 120 on your test. Good luck.